I am Yiannis Kanellopoulos, and with my colleague Evelyn, we're going to talk to you today about something that we realized working for when we've been working at the area of software quality for the last 10 years or so. So I'm going to tell you a little secret, but I'm going to disclose it now. The secret is communication. So this presentation is a Greek-Dutch production. I worked for SIG for 10 years already, the first 3 in Amsterdam, the rest here in Greece, where we help several clients that I'm happy to see also today among you. Would you like to say a couple of things for yourself?
Yeah, sure. So I'm Evelyn. I'm the Dutch part of this presentation. I work in Amsterdam. Well, let me introduce myself first. The last time I took a plane to a South European country, I got back with a cough, so I'm hoping Greece will treat me a bit better. I did some research on social success factors in software development. So that's my part of this presentation, and we're going to tell you a bit about how to balance this social technical complexity. So we make a great mix in the technical and social part.
Right. So I am the technical part, and she's the social part, and and of course the most enjoyable part. Why do we exist as a company, actually? Because we think we have a problem. As a planet, a society that's heavily dependent on technology and on software, we have a big problem. According to latest studies, around the globe there are approximately 12 million software developers. And if we assume that these guys, they write about, or some of you guys write around 10,000 lines of code each year, including the design and the analysis for those lines, then we produce something like 112 billion new lines of code every year. And from that big number, approximately 15% needs to change on a yearly basis. And imagine that you have also that every year, this is the 120 billion new lines of code, which means that there is also a pre-existing, every year we have also a pre-existing number of lines of code that need to be supported. So we think that this is not sustainable if we don't do anything, if we just produce lines of code without paying attention to the quality of those lines of code that are being produced, to the quality of the people that are producing, who are producing those lines of code, then most likely this digitalization of our planet, let's say, might not be that sustainable. So, and as I said, for years we've been assessing software systems. We do assess the quality of the code, but what we realized that even if you have a technically competent team that produces good quality software, still problems remain, still there are complaints from the business why the functionality is late, still there are issues in production, still there might be several issues while testing, and we keep wondering, what is the problem then? Because if, let's say, developers do a good job, why there are complaints? And the simple answer to that is that better communication between the guys that produce the software, we, the developers, and the guys who want to consume the services of the software we provide, which is the business, which is the end user, which is the final client.
Which brings us to... Was that me or was that you? I think I'm... Oh, yeah. Which brings us to the secret of this talk, and that's where we think that if you want to create better software, if you want to build higher quality software, then you have to listen to your people. And everyone heard the keynote this morning from John Papa, and he also said, well, it's about communication, it's about context, and that's, I think, that's the main message that we want to get across today. So I want to start with the more social part. The way you architect your software mirrors the way your organization thinks. And that means that every architecture that we create, every design that we create, is mirroring our organizational and communication structures. And that's also known as Conways Law. Conways Law might be familiar to some of you or most of you, but it's something that's being left unattended very often. And Conways Law states that if you want to improve your architecture, if you want to improve your code base, that you cannot do that without also addressing the operational parts. So if you want to create high quality software, then you have to create high quality communication structures. And it might seem very trivial, it might seem very obvious, but we see this being left unattended very often. And if you don't address this, then that might really negatively impact your development team's ability to drive efficiency and business value. So if we know that this is going on, if we know that the way that we communicate and that we collaborate is affecting our architectures, then why aren't we really acting upon it? And I think that that has something to do with our comfort zones, because we are kind of used to reflecting on our code. We are kind of used to reflecting on what we build and then make it better. But we are not as used to reflecting on how we collaborate together, how we communicate together. And I think if we want to create the best possible code, then we have to reflect on that part as well. And if we do that, if we understand what's going on the technical part and the social side, then we can also explain and understand a couple of other things better. For example, the deviation that we often see between plan and reality. We come across a lot of clients that implemented an architecture that didn't really look anything like the one they designed for. And I think that this happens to all of us, and not only in our software projects, but if it never happened to you, then please do come talk to us, because I'm very curious how you did that. But this is what we do for our clients. We look at their source code, we reverse engineer the design that's in there, and then we compare it to the actual design that's in front of us. And then we have some well, really interesting conversations as usual, because usually we are discussing something like this. An implemented architecture that looks nothing like the designed architecture. And then our first question is, well, how did this happen? How did you end up here? And then usually we don't get a lot of constructive and coherent answers. We do get a lot of surprise reactions. Is this really the architecture that we're working on? Is this really what we ended up with? And the fact that we get a lot of surprise reactions means that not everyone knows the IT landscape that they're working on. And if you're not really aware of what you're working on, if you don't really know what you're working on, then how can you ever improve it? And I'm not saying that deviating from a plan is a bad thing, not at all, because sometimes it's just necessary and the situation requires so. But what we usually see is that one person knows why things changed, or one person knows something that the rest of the team doesn't. And that's where it gets complicated. So we need to, kind of find a way to avoid that. So when we then ask a question, well, where did it go wrong? And well, the short answer, and that won't surprise you guys, is communication. Because actually there are three versions of every architecture. There's the designed one, the implemented one, and the one that lives in everyone's mental models. And if those three are not aligned, then you will never end up with what you designed for. Because if there is actually one thing that we have learned, like Yiannis said, from the past 16 years that we've been doing this, is that the key to effective architecture and effective high-quality software is actually good communication. So I will discuss a little bit more about these social things, feedback loops, communication patterns in a bit, but I think we have to start with the essence, and that's the most important part of every software development project. And that's people.
So, yeah, that was the title of an article I was reading like 20 years ago when I was a computer science student. It was on Wired, the magazine, and I found it very strange because 20 years ago everybody was talking about technology, that people will be replaced by technology and technology will save us, and we, the developers, the computer scientists, we're going to save the world. We are on top of this food chain, let's say. But after, let's say, now, and after 10 years working at SIG and 23 years after I read this article, I can say that I was wrong, because at the end of the day, the software still is being produced by people as the developers. It concerns people. People are going to use it and consume its services. So it's very important then to focus on that aspect. And for years, the aspect of software developers as the focus of attention from the organizations that they work for was neglected. So together with some guys from the University of Stuttgart, we started looking for this aspect, and we were inspired by a paper they first wrote, and it was about the happiness or the reasons of unhappiness of software developers. So they did a very nice study, collecting data from GitHub, And they came to this list. These are the top 10 causes of unhappiness to software developers. So these are the things that make a software developer feeling depressed. And of course, the first one is the problem solving. Usually software developers, they have to solve tough problems. They're not here for the easy stuff, they're for the hard stuff. They're for the struggle. But what we found out, and it was our, let's say, gut feeling all those years, was that the time pressures for the business and the quality of the code base they are working on, they are the next two most important reasons that they cause unhappiness to software developers. So when your business people tell you, we need this yesterday, and they tell it to you like 5 o'clock in the afternoon when you're about to go home, or if you are going to touch a piece of code and you start reading it and you understand that you actually cannot understand it, and you don't know what it does, and it's very lengthy and very complex, and you don't know how to test it. So these are pretty good reasons for a developer to feel unhappy, and we can kind of resonate with that, and we can kind of connect with that feeling. So then we are making it one of our missions to help developers becoming happier. And because if there are managers in this room, they will ask, why do we need to pay attention to these things? Why do we need to have happy developers, or why do we need to have developers who write good code, or what does it mean for me, code of high quality? Why do I need to pay for all those things and invest? We did another study together with the University of Amsterdam. At SIG, we have a model to rate the quality of your code. It's in stars: 1 star, very bad quality; 5 stars, very good quality. And we did an analysis on software systems from our clients and some open source systems. So we took the code bases and we took the issue trackings that they were logging all their time per issue, and we came to the conclusion that a system of 4 stars, actually you can repair faults or you can add new functionality at a fraction of the time when compared to a system of 2 stars. And usually this study can help us explain the business case to the management of an organization, or as to what it means for them investing in better tooling for their developers, better training, focusing on the quality of the code these people produce and how to guide them.
An important factor there, of course, well, is the communication part. So when we're talking about human behavior and interaction, well, communication lies at the very heart of it, and that's the most important part here. So when we're building maintainable software, as we call it, or high quality software, then we came to the conclusion that that is as much about coding as it is about communication. And luckily for us, both can be considered skills. And we all intuitively feel that coding is a skill that we can train, that we can get better at. But actually the same goes for communication. And that's why I really like this description of communication. It says, well, it's just the artifacts of your ideas. And that's not that different from coding. So when we are working on a project, I think the main thing is that we have to realize that we have to invest in both skills. We don't just need to get better at coding, but we also do need to get better at communication. I work at the software improvement group, so I'm kind of forced to love models and to really heavily use them. And that's not a bad thing, because I actually like them as well. But when I talk about communication, I like to use this one. And it's one of the most oldest and most widely accepted models of communication, and I like it because it's simple. And it states that if communication goes well, then it results in a message that's being understood, interpreted, and acted upon as intended by the sender. And that's what we all want. And it says that a typical communication flow consists of a sender that has to encode a message and sends it through a chosen channel to a receiver, and that receiver has to understand it, interpret it, and act upon that message. And then there can be some noise that can interfere with that process. But the hard part, the feedback part, that's where most things go wrong, because the receiver has to let the sender know that he understood the message and that he's going to act upon as intended. And this is all nice in theory, but we know that communication is the source of many failure, and that it can lead to a lot of misunderstanding and frustration. So it would be really good if we could somehow measure the effectiveness of our communication. And well, we can do that to a certain extent, because we can actually measure different aspects of the communication flows that we have. And one of them is feedback loops. And feedback loops are really important because they make out pretty much the most part of all our communication flows. So when I talked about Conways Law, well, your feedback loops are mirrored in your software and in your architectures and in your code bases. And then some might say, well, feedback loops, yeah, that's kind of a social thing, but we discovered that especially in software development, feedback loops are crucial. Because we all know that when we are working on a project, that timely feedback can actually mean the difference between clarity and confusion, because it can mean clarity over confusion. So we believe that feedback loops are really worth investing some time and energy in and identifying what's going on in your organization, in your projects, and how they are working. So I will talk about a few of them that we usually see in a couple of projects. This is the most simple version of a feedback loop, actually. It's, well, you have a developer, you have a system. The developer gives input to the system, and by means of hopefully automated testing, the system gives some feedback back to the developer. And then the developer can choose what he's going to do with that feedback. This is a very simple, effective feedback loop. It's closed and it's working. But we humans, we have this tendency to discuss everything with everyone and to involve as much people as possible because, hey, maybe person X needs to know this in 2 weeks, so maybe I should CC him already in this email, or I should just inform him. And that's where things get tricky. Because what happens if we add one more person to this loop, for example? What if we add the architect? Then we can see that this feedback loop isn't a loop anymore. Because we often see an architect designing an architecture in isolation and then handing it over to the team that's actually responsible for the implementation part of it. And then you get a distorted feedback loop. Because the developers in the system, they have a closed working feedback loop, but the architect might not get any feedback at all, nor from the developers and nor from the system. And that's exactly how you can end up with this huge gap between the implemented and a designed architecture. So what will work here is, well, you first have to see and reflect on if this is going on in your project. But if this is going on, then the simple solution here is to just get the architect in the loop so that he can get feedback from both the system and the developers and that you can make sure that the designed, the implemented, and all the mental models are aligned. Like I said, this is still a bit simple, and we have this tendency to include everyone. So what we see happening a lot in our projects is projects ending up with something like this. And I'm not calling this a loop anymore. I think this is feedback chaos, because this is what happens when you include everyone in one big loop and when you want to share everything with everyone. And well, you can see how hard it is to control this thing because you don't know what's going on. And this might seem very obvious on paper because we all can understand this is not what we want, but still we see a lot of these feedback chaos happening in the projects that we do for our clients. So what you should do, and what you might consider doing, is that if this is happening in projects that you're involved in, the first step is really reflection. Identifying who really needs to communicate with whom, and that's a really tough question to answer. But it's better to have multiple separate feedback loops that are closed and that are working than to have this one massive chaos in your project. We also quite often have a discussion like there are different forms of feedback. We have personal feedback and we have tool-based feedback. And personal feedback, of course, happens more on an interpersonal level when you're discussing with your peers what you're doing and where you should improve. It's more of a process kind of thing, and you have tool-based feedback that that tells you something about the code, where you should actually improve your coding skills. And then we have a lot of discussions like which one is better, tool-based or personal, what should I do, what should I focus on? And we believe that there is this false dichotomy between full automation and human intervention. Because we think that the best quality control combines tool-based measurement with this human intervention. And that at the end of the day, the best feedback loops are a mixture of automation and human intervention and tools. So I don't think there's one or the two is better actually, right? I'm not sure if you, you fully agree with that. But we see that the best projects that we assess are the ones who are combining personal and tool-based feedback in a good manner. Over to you for the non-functional part. Your mic is working.
It's working. Yeah, and going back a little bit to the previous slide, what we see in practice actually, because I said we measure software, which is something nice, but it can be boring. But when you see increasing in the measurements and in our rating, Most of the times, this is correlated or combined when peer reviews start within the teams. So when people, they see the measurements, they see the tooling, they find out all these complex parts, and then they discuss it together with the junior developers or their teams, and then they decide to act upon them. So measurement is a good thing, but if you don't combine it with teamwork and peer reviews, then you cannot actually make something good out of it. But about the non-functionals, well, paraphrasing a Greek proverb, like the good explanations make good friends. In Greece we say, οι καλοί λογαριασμοί κάνουν τους καλούς φίλους. If you don't set up the non-functionals when you start a project, then there is lots of ambiguity so as to what is good, what is not, what we should pay to attention, we as developers. So it's we believe at SAG that this is essential. And as Evelyn says, we have a weakness in models. We do love models and we love measurements. So, and when we started our practice back in 2000, we found out that there is an ISO standard. The ISO, at that time it was ISO 9126, now it's called ISO 25010, and it's a specialized ISO for software product quality. What this ISO does, which is as any ISO standard, it's very bureaucratic, but let's not go there. But it does something really, really useful. It gives a terminology that you can use, and you can have then a common way to discuss things with your peers and with your fellow developers. And this ISO standard prescribes 8 quality characteristics for a software system. The first one is maintainability, then reliability, security, usability, and so on. At SIG, we have developed 5 or 6 models for each characteristic here. I think we don't have a model for functional suitability and compatibility. And it's something which is, and the one which is fully automated, it's the maintainability model, where we assess the quality, the maintainability of the code. So how easy it is for the code to change. And we've been doing this successfully for all these years. We have analyzed more than 1,000, no, more. We have a benchmark of 1,000 systems that helps us to provide this rating. But can we move on?
Yes.
Thanks. So what we think is that the non-functionals, some of the quality characteristics that we saw in the previous slide, they need to be discussed in the beginning of the project. As we like to say, quality should not be an afterthought. It should be embedded in the process. It should be embedded from day one when you start developing the project. Or as a colleague of ours likes to say, maintenance starts as soon as you come back from lunch on the first day of your development, and you need to check the first lines of code you wrote that morning. Which is true, actually. So ideally, what we would like to see is the first picture. So the non-functionals are part of your iteration, are part of your sprint. So you take care of them while you're writing code, and we don't. And the process below, which is the norm in several projects that we've seen, is that people do write code because business wants it as fast as possible, as soon as possible. And at a certain moment, there is technical debt. There are lots of issues that stem from the quality of their work. So they attribute 1 or 2 maybe sprints just to restore things and then continue. So we think that it's better if you do the first one, if you from day one start working on maintaining the quality of the non-functionals high. And yeah, as I said, we have this model about maintainability. We think it's the most, let's say, relevant for software developers, and it's focusing solely on the code side of things. And yeah, here we, I guess, many of you might recognize that picture, which is, as we call it, the vicious circle of unsustainable software development. So you, somebody asks you to touch a piece of code or to write some new functionality or to support a piece of code that is written by another developer. Then you read this piece of code, you understand that you realize that you cannot understand what it does. So you don't want to touch it because you're afraid that you might break something, and then You do a workaround, you do a hack, you do a copy-paste, and then you write your stuff in that duplicate, let's say. Then the system starts growing in size and complexity, and imagine the growth rate, not for projects that there are 5 developers, but the projects that there are 30 or 40 or 50 developers, and most of them, they're doing the same thing in parallel. So the growth is exponential. And then you realize that you need more developers to throw at this code base so they can support it and they can do stuff, and the costs are increasing. It's more difficult to control the work of all those people. So, as I said, it's the vicious circle. So we again have lots of discussions, usually with managers, about quality and about why does my software need to be maintainable. And when we show them this graph, usually they realize it, but only 20% of the initial effort is for taking the system into production. The rest is support. So the better the work that you do initially, the more cost-effective will be your support, or the higher value will be provided to your business by your developers, because they will spend time in adding new features and they will not spend time in fixing bugs all the time. Yeah. So, and we have a way, let's say, to measure software quality, or actually software maintainability. We have this, as we call it, the star rating. And but before we go there, as I said, when we start applying our model, we realize that there are several pitfalls when one is using metrics. The first pitfall is that you are selecting only one metric and you're focusing there. So, for instance, you are selecting the unit complexity of your code, but you don't care about your fan in and fan out. You don't care about the duplication. You don't care about the number of your parameters or the architecture of your system, and you're simply focusing there. Then the other opposite of using metrics is the metrics galore. I deploy 1,000 metrics. I have tools that provide me measurements, several aspects, more than 50 aspects, and then I don't know where to start with. I don't know what needs to be fixed. I cannot prioritize because I have a plethora of metrics and and I'm lost. The other is, which is very interesting, is treating the metric. So when we come to a software developer team, and we show them, for instance, that the duplication is high, or that your units are pretty lengthy in lines of code, then they try to start treating the metric. So, for instance, concatenating the symbols, or trying to write shorter units of code just by concatenating lines, but that's not solving the problem. It's just you try to treat the metric and make sure that the metric is appropriate. But then this is something that has no value for the team. And the fourth one is the metric in a bubble. So it means that I have selected a set of metrics, but I'm focusing only in fixing a couple of them. And whereas my house is on fire, I am just trying to treat this beautiful flower which is in front of me and try to beautify it, and my house is about to collapse behind me. So these are the typical pitfalls that we see happening, and they were happening also, and they are happening also with our models, but we do our best to prevent that. So we try also to categorize the problems that we see with our in general in the industry, is that lots of tools, they give lots of false positives, including ours sometimes. We have lots of discussions with developers about that. Too many warnings, so you get too many messages, but you don't know where to start with. At least we don't do that. High price, tools are expensive, and I can easily imagine a couple of people here in this audience that can say that our tooling is expensive. It's difficult to configure. Also, the recommendations that they receive from those tooling, they're not actionable, so you get lots of feedback from a tool, but again, you're lost. You don't know how to utilize it. And also, several developers are complaining that there is no a uniform standard that they can all agree upon and start working on it and use it as the, let's say, the standard for their work. And these are most of those things we try also to deal with. We try to solve with the way we work. Evelyn, if you, by the way, that was a research we've done together with O'Reilly in United States. So we created a questionnaire and we had a poll and we had several developers answering all those all our questions, and that was the result of that analysis. So by watching all this and experiencing all those problems also ourselves in our daily practice, we came to this concise, let's say, set of guidelines that they concern three aspects: the code of your system, the architecture of your system, and the way your team is working. And then we divided them, and we say that when it comes to your code, there are 4 important things you need to pay attention. Your units should be small, your units should be simple, and in that way you can unit test them way more easily. Also, avoid duplicate the code. Copy-paste is not good, because imagine if you are copy-pasting parts of your code and then you need to either to fix them because they are buggy, or that you need to make a change in the functionality that this piece of code represents. And also keep the interface of your unit small, essentially have a low number of parameters in the units that you write. And then when it comes to architecture, so concerns need to be clearly separated in your modules. Coupling should be loose. Your key components, the key components of your architecture should be of a similar size. We don't want monoliths circled around by very small components. And also keep your code base small. Remove dead code. Don't put in your code base source code from third-party tools or from libraries or from other open source tools that you want to experiment with and then you forget removing it. And also about your way of working as a team, automate testing as much as possible, which is also related with the code side of things, about writing small units of code and simple units of code. And also write clean code. Write good comments. You don't have to write, let's say, a story as a comment, but you need to try to document the things that you do. And also the aesthetics of the code are important, and the way you write it. So, but these are, so we have clients saying, well, all these guidelines, they're good, but how can you quantify? Can you create some thresholds that then we can use them and make things way more specific when we have to steer our team? So for that, we studied what the industry says and what the academia says, and we created an initial benchmark based on some thresholds, which we calibrate every year. And we see that the thresholds every year are becoming stricter, actually. So what we advise software developers is that units should be limited to 15 lines of code, no more than 4, let's say, decision points within your unit. Also, your clones, your duplicates need to be less than 6 lines of code ideally, and there should be no more than 4 parameters in per unit. But this, here the verb limit is very important, because you will have very complex units. You will have functionality that might be complex, but the important thing is that you need to keep them at a very low. So we don't say don't do that, but what we say is try to manage it, try to keep it at very low. And for the architecture also we have some, you see here the thresholds, let's not go there. For the way of working, yeah, you all know the 80% industry standard about test coverage, and when we talk about clean code, it's apply the Boy Scout rule. Whatever you touch, just make it better than when you start working with it. And
yeah, so this is actually the first book that we wrote at the Software Improvement Group, Building Maintainable Software. That did pretty well, and the guidelines are pretty clear. But then again, like this whole talk is about, we say that's not just about writing code, but it's also about the other side, the social side of things. So we decided to write a second book, which is in line with our first book, on how to build effective software teams. And we came up with 10 guidelines for that as well. That are, yes, those are here. I won't go into all 10 of them. But these are ways that you can, guidelines that you can apply to also work on the effectiveness of your team. So not just focusing on the coding, but also how you work together and how you operate as a team. So there are these 2 books, and we are happy to share all these guidelines and the content of them if you want to know more details about those things. So we kind of bundled them into one package. So there are the 2 books, of course, which is the basis for everything that we are doing. We also developed the quality software development training, and there's the tool Better Code Hub that works with these guidelines that we mention in these books, so that you can actually check your code against the 10 guidelines and see how you're doing. That you can get immediate feedback, which helps your feedback loops improve. And sorry. Yeah. There's an open source version of it. Yeah, that's you can try it if you go to Better Code Hub. Then you can try and see how your code bases are doing, checking against our 10 guidelines. And in that light, we are actually setting up a new research project, following up on the developer happiness research that we've done in the past. We want to know more about that. We want to know more about the relationship between developer happiness, code quality, collaboration, and communication. So that's on our agenda. So yeah, if there's anyone interested in that, then please do come and talk to us after this session. And I think I think we're pretty much done with that talk. Yeah, thank you.
Thank you both.
If there are any questions.
And questions from our awesome audience.
Yes, keep your mic.
You mentioned something about the non-functionals. I didn't get that. What are the non-functionals you mentioned before?
Yeah, the non-functionals are related with this ISO standard that dictates the characteristics of quality that a given software system needs to have. So by functionals, we mean what the software needs to do from the end user's perspective or from the business perspective. The non-functionals are let's say, the quality aspects that the system needs to meet from a technical point of view. This is what I mean.
Anyone else?
I see one. Yes. I'm not seeing where the question is coming from. Listen to your people. Yeah. That's an interesting perspective as well.
Right. Yep. The title was how you can have high quality architectures. That was the actual title. They listen to the people is our message, and yeah, your observation is valid, I would say. But what we try to say is that all these guidelines they help towards establishing a common way of working and then a common way of understanding. And it's also connected to this research that we do about the unhappiness of software developers. And there the message is clear that the software developers somebody needs to take care of their unhappiness. Somebody needs to take care that there is lack of training, there is lack of time, or nobody cares about the quality of their work, and the only thing they ask for them is to deliver functionality. So essentially, we try to prescribe a context where we, as SAG, specializing in the technical side of things, and we try now to connect it with the social side. But your comment is valid. Thanks.
And one more question.
Yes. So if you have an entire team of software developers, say 5, 10 people, you have a manager, project manager, designers, people like this, how many of those people do you think should be responsible for thinking about these considerations of how communication happens? Is that me? Did you get that?
Were you asking how many people you think should be responsible for the effectiveness of the communication, or?
Yes.
Kind of. That was the question? Yeah. Well, I think everyone in that circle is responsible for the effectiveness of communication. I think if there are some, guidelines, maybe not the right word, but if you are setting a set of ground rules or guidelines that everyone needs to adhere to, like if you are making changes to a code base, then document it, or just tell people why you're doing things. Make sure you have some sort of shared sense of reality. And I think everyone needs to keep working on that, because if you all of a sudden wake up one morning and you decide, well, I'm going to change that in a code base and tell nobody, well, then that doesn't really help. So I think it's not one person who should be responsible for that. I think it's a shared responsibility.
Ouch. Thank you both.